His name is Blaise Pascal.
What?
A double rational function means a function that has two fractions in it, okay? That's why it's called double rational. And I believe that this might actually be almost exactly like the problem you guys saw in the book yesterday. So we're going to find the limit as x approaches 1 of this function. Now the problem is when you plug in 1, if you plug in 1, you get 1 over 0 minus 2 over 0. And we can't really evaluate that. So here's how you're going to do it. I'll give you a second to copy that down. The first step is to find common denominators. Okay? So I noticed for this particular expression I can factor it to x plus 1, x minus 1. A lot of times that's what you're going to do. You're going to factor that expression. Okay? And then when we do that, we notice that they both have an x minus 1 in common. So the only thing we need to do is multiply the left side by x plus 1, both the top and bottom. So then you'll get this expression. And now they have a common denominator. How do you combine two fractions with a common denominator? You just focus on what? The top, yeah, the numerator. So now we're just going to subtract x plus 1 minus 2. I'll give you a second to copy. Now we're going to combine the fractions by subtracting the numerators. X plus 1 minus 2 gives you x minus 1. So you'll simplify that. What do you notice the top and bottom have in common now? X minus 1, right? So for the next step, we're going to cancel those common factors. And I will say this about canceling common factors. This is only good for when x is not equal to 1. Why is that? Because if x was 1, you'd have 0 over 0. That doesn't necessarily give you 1 back. That's an indeterminate. But it doesn't matter because we're only evaluating the limit, not the actual y value. So once we get this, we can then plug in the x value. See, before when we tried to plug it in, we got 1 over 0 minus 2 over 0. Now we can actually plug in that limit value, which is x as x approaches 1. Okay, so what's the final answer here when you plug in 1? Huh? 1/2, good. Final step is to evaluate. So we're taking this limit value, we're plugging in for x, and I can just write this at the end here without going to the next. It gives us 1/2. So the limit as x approaches 1 is going to be equal to 1/2. And here it is. So if we put a point on this function, we try to drag it. What's the limit as x approaches 1? 1/2. There's a hole there, right? And there should be, because it's undefined, but the limit equals 1/2. And that's what we determined when we found the common denominator, canceled, and plugged in the x value. It was the same one, okay.